Hi there. I've got here a question where I've got to find out the distance from the end of the minute hand to the end of the hour hand at 5 o'clock. So at 5 o'clock, there's a little picture of my clock, and if I draw it bigger, there's a triangle with a minute hand here of 7, an hour hand of 5. I'm trying to find this distance here, and that angle in there is 150 degrees. Now, this is a trigonometry problem. You can't use SOHCAHTOA in this case because that only works on right-angled triangles. The sine rule, it won't work either because you need two angles and two sides. So we're going for the cos rule here. So I'll just write it out. Cos of A equals B squared plus C squared minus A squared over 2BC. Now, it's a good idea to put the letters onto the triangle that you've got. The cos A and the little a, those are an angle and an opposite side. So the cos A is the angle I know, and the A is its opposite side, the one we don't know. And the B and the C can go either way round. So I get cos 150 equals 7 squared plus 5 squared minus A squared divided by 2 times 7 times 5. Now I've got to solve this. I've only got one unknown, but I need to move some things around. I'm going to move the 2 times 7 times 5 onto the other side and therefore onto the top. Multiplying the whole thing together gives me minus 60.62, and that equals, I'm going to do the 7 squared plus the 5 squared now. 7 times 7 plus 5 times 5, that gives me 74 minus A squared. I'm going to move the A squared onto the other side, so it becomes a plus A squared. I'm going to move the minus 60 onto the other side, so it becomes a plus 60. So I end up with this 74 plus 60.62 makes 134.62. I'm running out of space. I'm just going to go up here. A equals the square root of 134.62, which is 11.6 centimeters.